Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science, Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various types of charts and its uses. So types of charts and their uses. So before going to see that, so we are going to create the charts. So for that, so present the data in visual method and then prevent distorting data, and we can able to present many numbers in a single unit, and we should also make a large data sets easy to understood and encourage the eye to compare the different pieces of data and then reveal the data at several levels of detail from the border view to the fine structure. Okay, so why are going to create the charts actually? So here, if you want to represent or present the data in the visual method, so that's why it is the main purpose we have to create the charts. So something, if you are going to represent the data, should be unable to grasp and observe not that much easily. So what we are going to do is, so if we are going to represent the same thing in the form of a diagram, so that many of the people, even unaided or uneducated people, also understood what it is meant for. And so we can able to prevent distorting data, so duplication data also can able to remove it, and then also present in many numbers in a single unit form. And we should also make a large data sets easy to understand and encourage the eye to compare the different pieces of data and reveal the data at the several levels of detail from the border view to the fine structure. So this is the one of the view of a bar diagram, so we're able to represent it in the form of a chart. Let's see one by one. So what are different types of charts we're going to have? So very first thing is that it should be used for comparing the items that are not dependent on each other, and we should also compare between the unrelated variables. Some other names what we're going to have should be bar chart and column graph, histogram, horizontal bar chart, stacked bar chart. So we can also going to have, sometimes we're able to call this bar chart as also as a column graph, or you can also call it as a histogram or horizontal bar chart or stacked bar chart. So normally these bar graphs or a family of chart that could go in, and that is going to be display quantitative information by means of several vertical rectangles. So mainly see here, so mainly this bar chart is going to be mainly used for comparing the items that are not dependent on each other, and should also compare the unrelated variables. And the other names of this bar chart should be bar chart, column graph, histogram, horizontal bar chart, and stacked bar chart. So normally the bar graphs are a family of charts that is going to be display the quantitative information, so by means of series of vertical rectangles. So here, so normally we're going to see different types of bar charts. So here what is going to show, so in x-axis I'm going to represent the percentage of population, and y-axis I'm going to have age category. So here what we're going to see is, so I can able to represent under 18 how many number of what should be the percentage of population, and under 18, 19 to 20 what should be the population percentage, and 25 to 24 age category what should be the percentage. So like this we are going to represent different types of air data in the form of a bar chart here. So normally this bar chart also frequently used to compare the multiple entities, or going to show how one or more entities going to vary over the time, and each bar or column represents the data element, and complete set of columns make up a data set. And this bar graph generally have one linear scale on vertical axis, and a category or sequence scale along this horizontal axis. And these charts are going to be useful when I'm going trying to compare the number of data sets or categories against each other. Okay, so these bar charts frequently used when I'm going to compare the multiple items. So if we are going to look at this diagram, so I can able to compare this three data for one variable, and again this three data is one variable, and this three data and this three data is one variable. So like this I can compare this one, how much comparison can be done by seeing this bar diagram, and similarly by seeing this blue color rectangles I can also able to compare what it is meant for. So that much easy is going to be done when I'm going to use of bar chart. So each bar or column represents the data element, and complete set of columns make a data set, and the bar graph generally have one linear scale on vertical axis and a category or sequence scale along the horizontal axis. So when these charts are going to be useful when I'm going to compare the number of discrete data sets or categories against each other. And the bar chart is also a column charts on its side, so we can able to represent the bars either in a horizontal way or vertical way also. So this is usually employed when there are fewer categories and when the differences between the categories are going to be larger. For a column chart, normally the x-axis lists the different categories, and the height of each category column shows the value. So normally what we are going to see is if you are going to use this bar chart or column chart, so normally the variables are going to be shown in x-axis, that what we call the horizontal axis. As I can also represent the form of vertical axis as well. And if I'm going to use this height of each category are going to be shown along the y-axis. Sometimes I can also show it as the x-axis. So if you listen to see this, the sales by quarter here. So the number of sales of particular item, and the number of sales of another item, and number of sales of another item. So same thing also can able to represent this one in the vertical form also. Okay. So these are the some of the different types of bar chart we are going to have. That should be column chart and bar chart. So column chart we are able to represent in the form of vertical, horizontal, vertical one, and also can able to represent in different forms. So normally, if I want to use a represent for a single independent variable, then it should be a single bar chart diagram, what we call it as. So similarly, if I'm going to use two independent variables for particular data, let it be A, B, C, D, I'm going to compare, then it should be multiple bar chart. So another thing is that within the bar itself, I can able to split it into portions. So this should be the different portion where you can able to split the bars in the different forms. And another thing is that where I can able to matches is rectangle bar is almost 100%. With the 100%, I can able to divide it. So like this, I can able to represent the different types of bar charts here. Okay. So stacked column chart. Just now what I said. Each and every rectangle is going to be mapped with 100%, and all this where each and every rectangle bar is going to be divided into different portions, what we call it as the stacked column chart. So here, see, if you look at this percentage, so it should be 1919 here, and it should be in 2000. So where this blue line is going to indicate the number of graduates of professional degree. Similarly, this orange color is going to be indicates that bachelor degree. and this purple is going to represents the associate degree, and some college degree blue color, and yellow should be high school graduation, some high school no diploma is going to be there, and less than 9 grade. So this kind of information I can able to represent in a stack of bar chart. It should be unable to represent if I'm going to use this in a single bar and then multiple bar. So where if you have same thing, if I'm going to represent in single bar means where I can able to represent this entire thing. Single bar is not at all possible. So we are can able to go for only this stacked bar. So 1990, and similarly in 2000, this should be looks like this. So instead of representing this under two different bar charts and a single bar chart, I can able to represent that should be stacked column chart. So that I can able easily easily understood and easily compare also where the data is going to be differ here. And stacked column chart, so here we can able to make use of stacking and grouping bars also serves to shows the relationship between the data sets, so helping the user to compare multiple items at various points in time, and it should also show how the relationship between the multiple items changes with time, and look for correlations or meaningful relations between the multiple data sets. So here, this stacked column chart is going to be group the bars and also serves to show the relationship between the data cells. So, which should be is going to be helpful, helping the user to compare the multiple items at various point in time, and which also shows the relationship between the multiple items, and also looks for correlations of meaningful relationship between the multiple data sets. So line graph. So this is the other kind of diagram we're going to be used for related variables, where the relationship is going to be changed over time. And these line charts are going to be good for showing the trends uh, of continuous data, usually involving the time, and the area chart is the line chart with an area between the line, and then x-axis is going to be shaded here. So similarly, if I'm going to take the line chart here, so it is going to be used for related variables and where the relationship is going to be changes over time. So if you look at this graduation, unit production of this graph. So how many number of units are going to be produced in every month I want to see. So January, February, March, April. So how many number of suppose let it be some item is going to be sold in month of January. Let it be 2000, and in month of March it should be something else, and like this I can able to identify each and every time for each month, and after joining all these points, what I get that should be a line chart here, and this should be the three-dimensional view of this line chart sales by month. Okay, so normally most of these line charts are going to be used in cricket matches like India and Pakistan. So how many number of scores are going to be over by over 5, 10, 15, 20, and 25 like this. So how many number of scores that are how many the graph what I'm going to get should be for India, and similarly for Pakistan like this, right? So this should be a visual view of this line chart for any kind of vertical application. So the area chart is also a line chart within the area between the line and the next area that is going to be shaded. So the line graph, what I shown here, this should be the view of this line chart, line graph, and the area of the this is the other kind of the graph what we're going to have should be area chart, where the portion of this line is going to be covered, and this is also the graph. We're going to have different type of the thing like this. So on the chart, on the type of graph, what we are going to have should be the pie chart. So this one is going to be used, which is going to be shown various parts of whole percentages, and the pie graph is going to be compare the components of set to each other to the whole, and the pie graphs are the members of entire family of proportional graphs. So this pie chart is going to be shown only for polar percentages. So the pie graph are going to be compare the components of the set to the each other and to the whole. And the pie graph are the members of entire family of the proportional graph. So now how we are going to this construct this means, so I want to know that how many percentage of people or how many number of students are going to be joined in medical, and then through management, and then the purchasing how much is done, and fundraising how many people. I want to know. So for this, first of all, what I have to do is make a circle here, and through make use of this protractor I can able to identify. So let it be the 40% of people are joined in Telegram. So make a 40% here, and fundraising will be of 10-20%, and this is for, so how many number of people are purchasing, that will be 50%, and to management. So like this I can able to construct the pie chart. Suppose if I'm going to show in the percentages form, then it should be like this. So the angle of area of each slice, what we called as a segment or wedge. So is the percentage of total circle as the data is going to be represents, and the pie graph data may be the contiguous or simultaneous in time, that may be linked more by meaning than the physical proximity or the sequence. Okay, so how this the angle what I'm going to obtain, this what we call it as a segment here, or I can able to call it as a wedge. So where this pie graph may be contiguous form or in simultaneous, what it may be, which is going to be shown in the time, and may be linked by meaning than the physical proximity or the sequence here. So this like this we can able to make the slices from this, and how much portion of this is going to be constructed we can able to see by taking the slice. And the pie graph normally should be contiguous in nature, or maybe it may be linked with the time as well, and should also be linked more than a meaning of physical proximity or the sequence. And another kind of graph what is going to be see here is a scatter plot graph. So normally this one is going to be used to show the visual representation of the relationship or correlation between the two variables using the Excel graph method. So normally instead of using the lines of connecting this, so the data points are going to be connected normally. So this, but here we are going to show only the data points here, so of the different colors. So the scatter plot for monthly unemployment rates by monthly rates from 1997 to 2000, I want to show it. So for that so this the green line should be the northeast country data unemployment rate, and this brown should be northeast one, and green should be middle east, and blue should be south, and this is for brown is for west. So like this I can able to show the different parts, so that I can able to identify the how many number of unemployment is going to be there monthly. I can able to show from 1 year to the another year. Okay, So this scatter plot is going to show the relationship between or correlation between the variables using the x and y graph method, and usually the lines connecting the points are not going to be connected here. Histogram. So histogram is another type of bar chart that is going to be display the frequencies or the relative frequencies in the form of continuous bars. These histograms can be used to see the shape of the distribution and determine whether the data are distributed symmetrically or not. So the histogram or bar charts is going to be display the frequencies or relative frequencies as well that form the contiguous bars, and histograms are going to be used to see the shape of the distribution and also determine whether the data are distributed symmetrically. So here what we're going to see here is that, so if I'm going to say the path retrieval times or central warehouse I want to show, so for that I'm going to take the time on x-axis and frequency on y-axis. So the only difference between this bar chart and then histogram is that there should not maintain any kind of space in between them. So normally the graph should be, bar chart looks like this, where we're going to show the relationship, not maintaining any space between the bars. So if the, but in histogram there should be continuous of this, there is no space between them, so that's why it should be called a histogram, and this should be the bar chart difference. So from this bar histogram itself we are able to construct the cumulative frequency curve and cumulative frequency polygon. So by constructing this relative frequencies, and we're able to use it also. So but here this histogram also be constructed based on the intervals. So intervals will have to be constructed here, 1 to 2 and 2 to 4, what is it, but here you can able to represent for a single variable, but here it should be of interval variables. So 10 to 20 how much, and 20 to 30 how much, 30 to 40 how much, like this. So let's see this histogram or bar charts, where what we have to be considered at what position for any kind of application. So histograms are sorting boxes. So there is only one variable and it is going to be sorted by this variable by placing them into boxes. And the number of pieces of the data on each box is going to be counted. And the height of a rectangle drawn on the top of each box is proportional to the number of pieces of that box. And so the bar graph is going to have different measurements at different items that is going to be compared. So the main question on the histogram is that how many measurements are there in each of the classes of measurements. And main question bar graph is that, so what is the measurement for each item. So here are the some of the examples. Okay, like situation and the bar graph or histogram, what have to be considered here. So before going to see that, so the histograms are not going to be called as sorting boxes. So this is the one variable and where the data is going to be sorted by means of variable into the boxes. So the number of pieces of data in each box is going to be counted, and the height of rectangle drawn on the top of each box is proportional to the number of pieces in that box. So normally the bar graph has several measurements of different items that are compared, and the main question histogram answer is that, so how many measurements are there in each of the classes of measurements. So the main question a bar graph answer is that, so what is the measurement for each item. So here are the some of the examples. So the number of pieces of data in each box is going to be counted. So where the bar graph is going to have several measurements of different items that are going to be compared. So the main question is that how the histogram answer is, so how many measurements are there in each of the class of measurement. So the main question A bar graph answer is that the measurement of each item. So here are some of the examples. So let us take a situation that, so if I want to compare the total income of 5 different people, okay. So for that situation, so what is going to prefer? Whether I going to prefer histogram or I can able to prefer the bar graph. So the answer is that the bar graph. So what is the revenue for the each person? Similarly, we have some measured revenues of several people that, so we want to compare the number of people that make from 0 to 10,000, from 10,000 to 20,000, from 20,000 to 30,000. So we have intervals here. So we have to measure the revenues of several people. So that to be in the form of intervals. So 0 to 10,000 how many, and 10,000 to 20,000 how many, and 20,000 to 30,000 how many, like this. So for that the question answer is that histogram is going to be preferred. So because how many numbers, many of the people are in each class of revenue. Next one, so if we want to compare the height of 10 basketball players in a team, so what is going to be preferred? Like, suppose we want to compare the height of 10 basketball players of a team. So whether I can able to prefer bar chart or I can able to prefer the histogram. So the answer is for bar chart itself. So where the height of each player is going to be compared. So for this, some X basketball player, what is the height? So under basketball player, what is the height, like this? So for this, no need of going for histogram. So here it is not the class interval here. Suppose see here, so we have a measured several players. We want to compare the number of players from 5 to 5 feet height, and from 5.5 to 6, and 6 to 6.5. So here it should be this histogram for solution. So because, so already the measures, and so in between from 5 to 5.5, and 5.5 to 6, and 6 to 6.5. So from 5 to 5.5 the number of players will let it be 20. So in between 20 have to there, and from 5.5 to 6 it should be 10. So I'm constructed, and 6 to 6.5 it should be around 15, right? So here maintaining here is the class interval, so that's why I can able to construct the histogram. So what are the various parts of the chart normally I'm going to see now? So normally axis is going to be there. So the axis is nothing but the reference lines in a coordinate system. So the x-axis is the horizontal reference and y-axis is the vertical reference. So this is the axis. This should be the horizontal reference, and this should be the vertical reference. And title, so title is also important of the bar chart, which is going to be describes the data the chart is symbolizing, and legend is the explanatory list of symbols on the chart, and labels are needed for linking the chart to the information being displayed. So if charted data has labels in the spreadsheet, so the label should be carried over to the chart. Okay, so the various parts of the chart should be axis, title, legend, and labels. So the axes are going to be reference lines of the coordinate system. The title is going to describe the brief overview of the chart, and legend is nothing but the explanatory list of symbols of the chart. And labels should be labels are going to be needed for linking the chart of information being displayed. And if charted data has labels in the spreadsheet, the label should be carried over the chart. So these are the various symbols of the chart. So this should be the x-axis, and this should be the y-axis. So these are the x-axis labels, and this should be the y-axis labels, and this should be the title of the chart, and this should be the color one. So what is the rectangle of each color is going to make for, and this should be the axis titles, what we called as. So what is this? States and the percentage of population vote. So like this I can able to show the different parts of the chart here. So what are the basic rules we have to be considered for creating the chart? So normally you have to be use some graph paper, or you can able to use a spreadsheet or a graphing program such as Excel. So decide on correct type of chart or graph. So determine the largest value number to be plotted on each axis, and make sure that the scale is large enough to use at least half of the paper in both the directions. Okay, so normal spreadsheet I can also use, or I can able to use graph paper, or I can use graphing programs such as Excel. So decide the correct type of chart or graph according to the application, and determine the largest number to be plotted in each axis. So let it be this one, and this one. So normally we're going to refer this is the one. And plot the independent or control label on x-axis, and dependent variable is going to be plotted on y-axis. So label the axis and then give the units to those labels. So all the graphs should have title, and good title should be always works y as the function of x. So instead of representing without these values, it should be looks clumsy what is meant for. And so what we're going to show, so what is this and what is this, we have to be clearly mentioned, and so that according to this I can able to measure the values here. So the plot the independent or control variable on the x-axis. So independent variables are going to be taken and dependent variable are going to be taken on the y-axis, and label the axis and give the user units to those labels. So all the graphs should have a clear-cut title. So the good title always works y is the function of x here. So most of the graphs is going to be short, should start at the origin, and there are some exceptions like graphing temperature. And if the lowest temperature is 37 degrees, start, and 37.5 degrees centigrade. So this is because of 0 to centigrade is the lowest temperature. So the number, the x-axis and y-axis with a regular numerical sequence or pattern starting with 0 to space out your data so it fills the entire graph. Okay, so what is the rule we have to be follow here is, so the most of the graph should start with 0 0. So this is the indication 0 x0 and y0, and there should be some of the exceptions may arise like graphing temperature. And if the lowest temperature is 37 degrees start to 35 degrees, so this is because of 0 degrees is not a lowest temperature. So number the x and y axis with a regular numerical sequence or pattern starting with 0, and space out your data so that it fills the entire graph. And if two or more lines are going to be plotted on a graph, so the key or legend is necessary. So without which should be of a different hue or symbol should be used for each line, and the color of the background of each graphs or line should be clearly distinguishable from other, and the color of lines on a multiple line graph should be distinguishable from each other also. If two or more lines are going to be plotted on a graph, so the key or legend is necessary with a different hue or symbol should be used for each line, and the color of the background of the graph and the lines of the graph should be clearly distinguishable from each other, and the color of the lines of multiple graph should be distinguishable from each other. So this should be this key or legend. So how much of size it should be, let it be 10, let it be 113, 151 like this. So this, by seeing this, we can the user can easily understand what is meant to and easily observe what is the key value. So the color of the background of the graph should also be clearly distinguishable from each other. So normally, what is should be the general advices we are going to use for creating a chart here. So normally, all the time the graphs what you have done should be simple one. So make the data should be do talking and don't leave upon your chart with extra colors or 3D or pictures. So interesting data captures audience attention more than any graphic or special printing effect could be. And meaningful titles and labels should also be used, so let the audience think about what is the data means, not what the data is could be. And be truthful with the axis, don't exchange the scales or perspectives to gain the falsely perceived advantage. So all the time, so the graph should be meaning simple one, so makes the data should be do talking, so don't living upon the chart with the extra colors, 3D pictures. So instant interesting data captures the audience attention more than any graph or special printing could be. So use the meaningful titles and labels here. Be truthful with the axis, don't exchange the scales or perspectives to gain false or precise advantage. So some of the basic rules what are going to follow for 3D should be, so 3D may not be a good idea because the data may appear distorted and can be misinterpreted or may be misleading. So the demonstration of the problematic 3D perspective, so the chart on the left should be clearly shown the Clinton edge of the dole in the Florida. And when the Excel shows this data in 3D format, it is impossible to tell anyone one or if it is a tie itself. So whatever the 3D data are good to represent it, so that should not be good idea because the data may be distorted and can be misinterpreted and then misleading. So the demonstration of problematic 3D perspective, uh, it is going to be shows the Clinton edge of something. So when the Excel shows this data in 3D format, it is impossible to clearly tell if anyone won or it was tie also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.